Good morning students. Welcome to 11th standard chemistry video class. We are discussing lesson 10 chemical bonding. In our last video class we completed up to polarity of bonds. In this video we are to start with the next topic, valence shell electron pair repulsion theory. Before starting with the important principles of valence shell electron pair repulsion theory, we will discuss the introduction to valence shell electron pair repulsion theory. In our earlier classes, we discussed the topic Lewis concept of structure of molecules. Lewis concept explains about the relative position of atoms in the molecules and how the electron pairs get shared between atoms in the molecule. But Lewis concept does not explain or does not predict the shape of the molecules. Hence, along with Lewis theory, we are having valence shell electron pair repulsion theory to predict the shape of molecules. Now, let me discuss important principles of valence shell electron pair repulsion theory. Important principles of valence shell electron pair repulsion theory are as follows. First point, the shape of the molecule depends on the number of valence shell electron pair around the central atom. Here in a molecule, the central atom is surrounded by valence shell electron pairs. Hence, the shape of the molecule is given by number of valence shell electron pair around it. Second point, there are two types of electron pairs, namely bond pairs and lone pairs. The bond pairs of electrons are those shared between two atoms, while the lone pairs are the valence electron pairs that are not involved in bonding. Here we are having two types of electron pairs, namely bond pair electrons and lone pair electrons. Already we discussed about bond pair and lone pair electrons. The electron pair which is involved in bonding is called bond pair electrons. The electron pairs which do not involve in bonding is called lone pair electrons. Third point, each pair of valence electrons around the central atom repels each other and hence they are located as far away as possible in three-dimensional space to minimize the repulsion between them. Here, the central atom contains pairs of valence electrons and they repulse each other. In order to minimize the repulsion between the pairs of electrons, they are located as far away as possible in three-dimensional space. Fourth point, the repulsive interaction between the different types of electron pairs is in the following order. Lone pair is greater than lone pair greater than bond pair. It is shown here. Here the lone pair of electrons are localized only on the central atom and interacts with only one nuclei, whereas the bond pair electrons are shared between two atoms and they interact with two nuclei. Here lone pair electrons occupy more space and have greater repulsive power than the bond pairs in a molecule. This tabular column explains the shapes of molecules predicted by valence shell electron pair repulsion theory. Consider the molecule ABX, where A is the central atom and X represents the number of atoms of B covalently bonded to the central atom A. The lone pair present in the atoms are denoted as L. This tabular column contains number of electron pairs, molecule, number of bond pairs, number of lone pairs, shapes, molecular geometry, and example. First, we will start with number of electron pairs equal to 2. The molecule with the formula AB2. It contains 2 bond pair electrons and there should be no lone pair electrons. This molecule contains 2 AB bonds. Hence, the shape of the AB2 molecule is linear. The molecular geometry is shown here. Examples for this AB2 molecule is given here. BeCl2, HgCl2, CO2, CS2, HCN and BeF2. Next, we will discuss number of electron pairs equal to 3. The molecule with the formula AB3. It contains 3 bond pairs electrons and there should be no lone pair electron. This molecule contains 3 AB bonds. Hence, the shape of AB3 molecule is trigonal planar. The molecular geometry is shown here. BF3, BCl3, NO3 minus, BF3, CO3 2 minus, HCHO are examples for AB3 molecule. Again, let me discuss number of electron pairs equal to 3. The molecule with the formula AB2L. It contains 2 bond pairs electrons and 1 lone pair electrons. Hence, this molecule contains 2 AB bonds and 1 lone pair electrons on central atom A. Due to the presence of 1 lone pair electrons, the shape of the AB2L molecule is bend shape or V shape. Molecular geometry is shown here. SO2, O3, PbCl2, SnBr2 are examples for AB2L molecule. Next, let me discuss number of electron pairs equal to 4. The molecule with the formula AB4. It contains 4 bond pairs electrons and there should be no lone pair electrons. This molecule contains 4 AB bonds. Hence, shape of AB4 molecule is tetrahedral. The molecular geometry is shown here. CH4, CCl4, CCl2F2, SO4 2 minus, ClO4 minus, NH4 plus are examples for AB4 molecule. Again, let me discuss number of electron pairs equal to 4. Here, the molecule with the formula AB3L. It contains 3 bond pairs electrons and 1 lone pair electrons. This molecule contains 3 AB bonds and 1 lone pair electron on the central atom A. Due to the presence of 1 lone pair electron, the shape of the AB3L molecule is pyramidal. The molecular geometry is shown here. NH3, PF3, ClO3 minus, H3O plus are examples for AB3L molecule. Again, let me discuss number of electron pairs is equal to 4. Here, the molecule with the formula AB2L2. It contains 2 bond pairs electrons and 2 lone pairs electrons. This molecule contains 2 AB bonds and 2 lone pairs electrons on the central atom A. Due to the presence of 2 lone pairs electrons, the shape of the Ab2L2 molecule is bend-shaped or V-shaped. Molecular geometry is shown here. H2O, OF2, SCl2 are examples for Ab2L2 molecule. Next, we will discuss number of electron pairs equal to 5. Here, the molecule with the formula Ab5. It contains 5 bond pairs electrons and there should be no lone pair electron. This molecule contains 5 AB bonds. The shape of AB5 molecule is trigonal bipyramidal. The molecular geometry is shown here. PCl5, AsF5, SOF4 are examples for AB5 molecule. Again, let me discuss number of electron pairs is equal to 5. Here, the molecule with the formula Ab4L. It contains 4 bond pairs electrons and 1 lone pair electrons. This molecule contains 4 AB bonds and 1 lone pair electron on the central atom A. Due to the presence of 1 lone pair electron, the shape of Ab4L molecule is seesaw. The molecular geometry is shown here. SF4, XeO2F2, IF4 plus, IO2F2 minus are examples for Ab4L molecule. Again, let me discuss number of electron pairs is equal to 5. Here, the molecule with the formula Ab3L2. It contains 3 bond pairs electrons and 2 lone pairs electrons. This molecule contains 3 AB bonds and 2 lone pairs electrons on the central atom A. Due to the presence of 2 lone pairs electrons, the shape of Ab3L2 molecule is T-shaped. The molecular geometry is shown here. BrF3, ClF3 are examples for Ab3L2 molecule. Again, let me discuss number of electron pairs is equal to 5. Here, the molecule with the formula Ab2L3. It contains 2 bond pairs electrons and 3 lone pairs electrons. This molecule contains 2 AB bonds and 3 lone pairs electrons on the central atom A. Due to the presence of 3 lone pairs electrons, the shape of Ab2L3 molecule is linear. The molecular geometry is shown here. XeF2, I3 minus, IF2 minus are examples for Ab2L3 molecule. Next one, number of electron pairs is equal to 6. Here, the molecule with formula Ab6. It contains 6 bond pairs electrons and there should be no lone pair electrons. This molecule contains 6 AB bonds. The shape of Ab6 molecule is octahedral. The molecular geometry is shown here. SF6, IOF5 are examples for Ab6 molecules. Again, let me discuss number of electron pairs equal to 6. Here the molecule with the formula AB5L. It contains 5 bond pairs electrons and 1 lone pair electron. It contains 5 AB bonds and 1 lone pair electron on central atom A. Due to the presence of 1 lone pair electron, the shape of AB5L molecule is square pyramidal. The molecular geometry is shown here. BRFI, IFI, TEFI minus XeOF4 are examples for AB5L molecule. Again, let me discuss number of electron pairs is equal to 6. Here, the molecule with the formula AB4L2. It contains 4 bond pairs electrons and 2 lone pairs electrons. It contains 4 AB bonds and 2 lone pairs electrons on central atom A. Due to the presence of 2 lone pairs electrons, the shape of AB4L2 molecule is square planar. The molecular geometry is shown here. XeF4, ICl4 minus are examples for AB4L2 molecule. Finally, we will discuss number of electron pairs is equal to 7. Here, the molecule with formula AB7. It contains 7 bond pairs electrons and there should be no lone pair electron. It contains 7 AB bonds. The shape of AB7 molecule is pentagonal bipyramidal. The molecular geometry is shown here. IF7 is example for AB7 molecule. Hence, we completed the topic valence shell electron pair repulsion theory. Let me stop up to this topic. The remaining topics that we will discuss in our next video class. Thank you.